Here we are, guys. Hi, everyone. Vasa live coding peel right, right now, live on YouTube. You ready? Hello, Frog. Let's wait for someone to come and then we can start. Hi, Max. Glad to see you here. Let's wait just a couple of minutes and then we can start. Today we will see the fixed inflation contract, which is a contract that uh, we just developed uh, for the purpose of the Tyrian SOS design. But I want to make it to be general purpose. It is general purpose, but not so much. I want to try to let it be more general purpose. I don't know how to explain, but you will see the code because all the pieces were that we working on, like for example, farming contracts or investments fund, are already general purpose. Maybe the investments fund, no, the new version is, but I can easily transfer code from one side to the other side because it is extremely simple and compatible with the actual version, so no problem about that. So you can also understand how the architecture works, and it can be a very interesting coding session. Please, I just wrote it on Discord and Telegram. If you have questions or comments, please write down on YouTube because so I can be focused just on the YouTube page, the streaming one here in StreamYard. So I am not forced to go to see a lot of pages, a lot of applications, and also I can highlight the comments like this. Hi, Frog. Okay, I think that we can start. Let me just share the screen. Share screen. Entire screen, screen number 1. Yes. Okay. Just let me go here. Do you see the screen, guys? Do you want me to increase the font or decrease? Just let me know, please. So let's go into the OS Fixed Inflation Manager. And the name, I think that is the first thing that I need to change. First of all, we are on the branch block to time. So everything that, as we already said in one of the last coding pills, now the time is expressed in seconds, not in blocks anymore. This is for compatibility with all the side chains like Optimism, Arbitrum, Polygon, etc. But I think that we can create a new branch over here, switch to new branch, create new branch, general purpose, fixed inflation. I think that I put the wrong name, so I need to create another one from block to time, general purpose fixed inflation. Okay, so I will delete the old one in a second time. And it must just switch automatically to the new branch, correct. So the first thing I'm going to do is to copy this and go inside the external package of the components and call this Fixed Inflation Manager. It already exists. Oh, really? Wait, just... Wow, this is kind of strange, guys. Fixed inflation. Okay. This is for routines. So I think that we can rebrand this in covenants routines manager. Covenants routine manager. I forgot it. I wrote tons of code here. So okay. So the first thing I did is to change this, and now go to change this. This can be the Fixed Inflation Manager. Fixed Inflation Manager. Fixed Inflation Manager. And also this, I can change this. Okay. Now I need to change also this. Okay. And this should work. Now let's do the first commit. I will insert this and this covenants routine manager. And that's it. Okay, so we can start to work here. So why the Fixed Inflation Manager is not so general purpose? Let's say, first of all, how let's take a look at the state of art. How our fixed inflation manager works right now. It means the OS tokens, and first of all, it is, as you can see in the code, it is extremely hard coded that it can mean just DOS, which is an item. This could be created in a general purpose way, and we will do it during this journey. But this is the first thing. Second thing is that not all tokens used in organizations are items. So we need to introduce something that let people can use their own mint methods, like for example the Open Zeppelin one, which has the mint method with the parameters, or any other kind of mint method, because the mint method is not standard into the ERC20. And so this is the first thing we need to change. Second of all is the business logic of the routines. The fixed inflation, which just mints the tokens, and then split them to sending OS to the farming contract with OS as we work, then sell the remaining OS part for Ethereum using Presto, and then split this into three, sending it to three sources. The executor of the transaction that will receive is its reward, the company treasury, and of course the treasury splitter that then will do in cascade mode the other splits. But this is, as I said, extremely hard-coded thing, and I want to let it be more general purpose. How we can do this? First of all, we need to understand how the fixed inflation works. Sorry, not the fixed inflation. The managers system works inside the organizations. So let's see. We see the organization over here. Organization, which is the address that you can see when you click on the Ethereum OS organization on the Ethereum OS website. You will see Ethereum into the address bar, Ethereum OS organizations, and then an address. That address is the address of the organization, which is this. And organizations contains some components. Every component is made by a key and a location. The location, of course, is the address of the component, like for example the fixed inflation manager, the common treasury, the investments manager. And the key, I think that it is spelled it represents in the unique way that component. Let's see, for example, when we did the OS app number 3, if I remember correctly, the one that fixes the problem, inside the investments manager, all that we did was we knew the key of the investments manager and just went there and replace the location of the investments manager. So everything worked on cascade, because, for example, the treasury splitter doesn't know the address of the investments manager. He just asks to his host, which is the organization, give me the address linked to this key. And that was the new address of the new investments manager instead of the old one. And we can have here something called Grimoire, if I remember correctly. Let me see here, library, knowledge base, Grimoire, where all the base managers are. You see the component key called the component of the treasury manager, which is the common treasury. In this case, is this. The state manager that saves data, like for example, what is the actual fee on transaction for the covenants farming or whatever into the state manager. Then there is the key of the microservices manager, and there is the key of the proposals manager. So every key you just go into, if you know the keys, you just go inside the organization and just call the get method with the key, and it returns you the component address. Of course, there is inside the organization the event called component set, which returns you all the keys that has been set inside this organization. And you, into the front end, just call list with all those keys wrapped from the events, and you can fill up the web page of the organization. So it is totally dynamic. Sorry guys, before to continue, I want to introduce a friend called Atox.
Hello.
And how's it going?
Good, good.
Thank you very much to be here. Atox will just be my I don't know how to say code colleague in parent mode. We can talk while we are while the code goes on. So because it is so strange to talk to a camera in a empty room. I know that you are watching me maybe, but having someone that who can talk to and that have good questions, and of course can help you find bugs where you do not see them, because the most important thing is to have a counter alter. Most of the programmers just use the auditing method, but I prefer to have another skillet, comrade, let's say, that can help you and just let you be notified about something that is not okay. And this is how we worked in the last period, for example, with Davey. While he was writing the documentation about the new organization, he just found a lot of good stuff to edit inside the smart contracts in order to have more performing contracts. And I hope that Atox will do the same for me right now and for us here in live. So Atox, I don't know where when you started to watch the live, but I was just explaining what we are going to do.
Mm-hmm.
It was the way how the components approach works inside the organization. So just to recap, to have a quick recap, we have the organization, which is the address that you can where you can find the organization inside the front end, and you have a lot of components. All components are well known by a key, and all the keys can let you find the address of the components. For example, the proposals manager, it is a component. The fixed inflation manager is a component. The investments manager is a component, etc. So you just take the component set event. You just search for the component set event inside the front end through by navigating the logs on the blockchain. Go get all the keys and just find all the components of these keys. And because of the name of the keys are, at least for the standard components, are well known inside the code, you can easily understand, for example, what is the address of the treasury manager, the proposals manager, where to do proposal, etc. So I just started just explaining how the fixed inflation code work and how we can let it be general purpose. Let's say.
I have a question.
Yes.
So what does a contract need to become a component? Like, is there a standard for a component if someone wanted to make like a new one?
I think that I created them in really general purpose way. I don't think it needs something. At least um, it must be a smart contract.
Right.
Okay, so a component cannot be a wallet.
Hmm.
Okay,
Right.
and I think that this is it, because as I remember, I wanted them to be extremely easy to let people create.
Right. And
And
how does the process of like joining a component with an organization work? Is it just any contract that the organization wants to declare a component, or uh, is there some like specifications within like either the organization or something like that?
all this game is played at factory level, let's say.
Hmm.
Once you have the organization, so all the organization contract and all the components, you can merge them as you wish. For example, in the first version of the organization factory, I just figure out, because there is the organization factory right now, which is the one that we used to create ours. Let me see. I think that the only at least in this version, I will change for the new factory. The only mandatory component is the treasury one, I think.
Right.
Let me
For the
check.
organization. So that's the only thing the organization needs to work. Now, because what I'm thinking is, can you make, for example, the Aave loan contracts a component for the organization? Like thinking of in terms of interoperability.
I don't know how the other loan contract works, but I think the answer is yes.
Right.
Because it
Because
is,
that
you
would let
know,
you like execute in theory, right? Execute, for example, a loan transaction from the organization directly if it's attached as a component, right?
on the treasury. You see, you mean?
Yeah, I mean, you have the treasury, and the treasury says the Aave loan contract is a component. So,
Mhm.
in my understanding, the organization is no quote unquote aware of this contract, right? So it could interact with it and do something like directly on chain take out a loan instead of having like an end user do it on its behalf.
Yeah, in that case, the all the flow will be. I am the other. First of all, there are two type of components: active components and non-active components. What it
Hmm.
means that active components can edit the status of the organizations. Okay,
Okay.
for example, two. In this case, the other component that you are describing is an active one, because it just must have the permissions to transfer
Keys.
assets from the
Right.
treasury manager.
Right. Right. Hmm.
Okay, so the idea, the way it works is this: you call the treasury manager, just call the transfer method as
Hmm.
the other component, I mean,
Right.
okay? And the treasury manager, which is a lazy init capable element,
Hmm.
just go to asks to its organization, because all the components must know what
Hmm.
is the organization that we belong to.
Hmm.
They belong to. Sorry. Must know if this component is authorized to write.
Right.
Okay. Once the organization said yes, okay, your other component is a component of this organization and is active,
Hmm.
the transfer can be done.
Right.
So the other component is triggered somehow by proposal,
Hmm.
by external use, etc.
Hmm.
It asks for money to the treasury manager, and then does what it needs to do.
That's actually pretty cool. Because
Okay.
it's like you can interact with any contract. Now,
Yes.
let me know if you
Yes.
don't want me to keep asking questions, and we can keep going. But I have one
Mhm.
more. What are your thoughts on these new 6551 contracts? Like, have you seen about those that new standard?
Um, no, never heard about it. But if you pass
Yeah.
me the code, I can check.
Uh,
But not right now.
right, right. I'll give you a
I
thing. I'll give you a thing later, but
yes,
just conceptually, because you said you told me earlier that an address cannot be a component, right? The thing
yes.
is, the thing is that they're pushing now these smart contract wallets, which are basically an NFT contract
Hmm.
that is a wallet.
Okay. Okay.
So,
Okay.
mhm.
I just wanted to. I just answered to your first question because it is on topic on what
Right,
we
right,
were
yeah.
working on.
Let's talk about it later, and we can just keep
Okay.
going on this.
Okay. The second one is off topic, but why I wanted to respond it on this because it is the methodology that we described to transfer money is the same that we used inside the fixed inflation to to see because to see if the fixed inflation manager contract can mint OS tokens.
Hmm.
So when you call the method which is swap to ETH, okay, it just calls the OS minter somewhere. I think here in received comments, received tokens. Let me see where here iOS minter just minting the tokens, and the iOS minter, which is another component, it just asks the organization if this fixed inflation manager is authorized to mint tokens.
Right.
One, the tokens are minted. They are elaborated. Let's say so, sent to the farming or to the treasury splitter. Let's say, and all the flow works. And this is what the logic that I want to change because as you can see here, you have here the treasury splitter manager hardly linked inside the code, and also the treasury manager one, which is the standard. Let's say and DOS farming also. And this all this logic I want to change. First of all, I talked about the grimoire, and we have multiple grimoires here as well. The keys of the components are stored. We have the base one for the base components, company key, state, microservices proposals. Then we have the external ones, which are the new one. For example, the investments manager, the delegations manager, the treasury splitter manager have other component keys. Why this
Hmm.
difference between base and X? Because base components are the same, so are the same of the old DFO hub
Mm,
architecture. So
right.
for me, in my logic, that was the base. Now in the new code, everything is changed, but for me, it was the base. And then there are the the extra components, let's
Hmm.
say, that can have all the stuff. And then there are also the Ethereum SOS components. And the old fixed inflation manager was part of this because we have, you see, the OS farming, the dividends farming, the token
Hmm.
minter, which is the iOS fixed inflation, and the token minter, which is the iOS minter. And all this logic, it is hard, let's say hard cable in the old fixed inflation manager. I want to let it be general purpose.
Right.
So let's start from here. Okay. So what we have here, first of all, we have the swap data because the fixed inflation manager through Presto is able to swap the tokens that you mint.
Right.
Then there is the update token percentage, and this can be done only or using the serverless governance.
Hmm.
So you have the new value. Update inflation data is used because the inflation data change every year. So let's say that you never change the percentage. Every year, the fixed inflation contract updates the total supply, which is new
Right.
respect of the old one. So every time you mint something, you are minting the X% of the total supply of the first year the first year when the inflation started, and every year it updates.
So it's minted when on the yearly basis, and then it's distributed over the year.
No, 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 no. It is minted every day, okay,
Okay.
but the value is fixed in a yearly
Okay.
base.
Okay. Okay.
Executor reward percentage. Okay, this is the percentage in this hard cable, the percentage of the executor that can um, keep the reward before executing the call. Rest address. Last token total supply, as I said, when it was updated last time and what was the total supply value. Last token percentage, so what is the actual token percentage. And last inflation per day, which is the calculus of about the years in 360 years, 360 days, if I remember correctly, etc. And then there is the last day where the swap was called. So the swap is called every day. So every day this variable is updated, and then there is the interval. In our cases, is 1 day. So it means I don't remember how many seconds,
Mhm.
and in blocks it is
Like 6,000.
six 400, sorry,
Hmm.
6,400. And where the next one will be, according to the last swap and swap to it interval. Um, all this stuff, of course, are used even for to fill up the front end,
Hmm.
of course. And then we come to the hard part. Swap to it is the method that everyone calls in order to execute a swap. Let's say the split, the inflation. I think that we can change name here in execute first of all. The parameters are mean amount, which of course is the parameter used during the swap for in order to not be sandwiched.
Hmm.
Okay, and then there is the executed reward receiver, which is the one that will receive the reward,
Hmm.
which it and here you can specify an address different of the one that
That
does
calls.
the call.
Right.
Yes,
I have a question. How much gas, like average, does it spend when you swap?
I don't remember. We can check. Just give me a second. Just go to the to the treasury. You can see it, but I think that the gas is not so much. 655, 655.
Right. Like, wait.
Wait, yeah. No, 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 no. This is the gas.
Right. How much
Then
did you
you
spend?
have, yes. This is the transaction. I don't think that here you have
I think it's a bit
the
lower. Oh, gas price here. Oh, it was just a tiny little bit. No, transaction fee $76. Okay.
okay. Oh, sorry.
Yeah.
Okay. Uh,
And
and here we are.
that's a simple. When you execute that on inflation, it's going to be a swap between the newly minted OS and ETH,
Yes,
right? Okay.
yes. So the first thing I'm going to change is the execute, the name of the method, which is not swap to it anymore, but execute. Why this? Okay, because the first thing is it is not uh, sure that your fixed inflation will swap tokens. Okay, so the first distinctions I want to make here is there are components that will receive tokens. There are components that will receive swapped it. Okay,
Yes.
So the first thing that I can write down here is okay. The first thing is function uh, pure token components external view returns bytes 32 memory component keys address memory components and then and sorry and also the u in 256 memory percentages because every single address here will receive a percentage of the tokens.
Mm-hmm.
And here we have if components, but I don't like these names because they suck.
Call them native token, or I don't know.
Row. Like this.
That's good. That's good.
Okay. Okay. How this logic will work? How this logic will work? First of all, let's insert here into the destination one. What is destination? In our case, destination was the company treasury, okay?
Mm-hmm.
So our wallet that we can change it. We can change because it was ours wallet, okay? And we supposed to change. We, for example, let's say we wanted to change it. We cannot change the percentage, of course, of the of how many tokens we will receive Ethereum swapped tokens we receive, but we could change the destination, so the address where these tokens were gone. And this is what I've invented here. There is the wallet owner, okay, which is the wallet of the company, and then there is the destination wallet, which is the ones that receive the tokens.
Okay.
Also
Oh, I love
see the wallet percentage, okay?
that. Mm-hmm.
When the msg.sender is the destination wallet, okay, you can change, of course, the destination of the funds.
Oh, okay.
Okay? And of course,
As long as you are the destination wallet.
exactly. No, you must be the destination wallet owner.
Right, right, right.
So if you call set destination, the msg.sender must be the old destination wallet owner. Okay?
Mm-hmm.
And you can change in just one method the destination wallet owner, you can change it, and the destination wallet address, of course. Not the percentage, as I said, the percentage is read only. Once the contract is set, you cannot change percentages because of question of transparency. So transparency, of course. All my set methods try to give back you the old method, the old values. For example, in this case, this method returns the old destination wallet owner and the old destination wallet address. Mm-hmm. With this call, you can also set them to address 0. When they are set to address 0, you are not able anymore to receive tokens.
Okay.
Okay. And that's it. And this, I think that this can stay like this. Okay?
Hmm.
What I want to check right now, we now need to to have something more here. First of all, the destination will receive tokens or swapped ETH. So we need to introduce here another value called bool value is in F. And again, this is just read only. So once you set inside the contract, you cannot change it anymore.
Right.
And that's it. This must be checked also at creation time because first of all the percentages are are expressed in ways, okay,
Hmm.
and they must be checked in order to be extremely sure that everything works well.
Hmm.
What this means, let me see, let me just understand. This is now I'm going to explain how I always manage the percentages inside our contracts. Let's see, for example, you have five components that will receive the percentage. Okay,
Hmm.
you must specify the percentage only of the first four. So if the array components is made of five elements, the
Hmm.
percentage is made of four elements because the last one will receive the subtraction
The
of the
remainder.
other one.
Right.
Exactly, exactly, exactly. Okay, and this is extremely important. But we need to be a little. We here have another level of difficulty because if value is ETH here, okay, so if value is ETH is true, the row token components must be the percentages of the row token component must be equals to this
Percentage. Okay.
because this must be no no this no 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 no. We can have many cases here. This is why I wrote this contract in a general purpose way, but it's a challenge right now because we have more level of difficulties. Let's
Hmm.
say because, for example, we can let's suppose that we don't have components, any component that would receive swapped tokens. So
Hmm.
you don't have to swap Ethereums,
Hmm.
right?
Yep.
That could be a problem because so if what happens if destination is not set, so it is zero,
Hmm.
okay, and the swap token components is zero, so everybody receive raw tokens.
Right.
How to
Well,
manage the percentage?
because you're trying to calculate. I
We
don't
are
understand quite well the structure of the problem. Uh, because like okay, so we're minting tokens from inflation, and
yes,
then you are saying that a percentage of that is getting swapped, right? So now you're having two balances, which is the remainder of the tokens that you minted and the tokens that you swapped, correct?
exactly. But how you can take the percentage of the remaining tokens to swap?
of the before you swap them. You mean?
You can take it before to swap.
I'm trying to like follow the string of events towards the problem, right? So tokens are minted, like, and the number of tokens minted is set through that yearly inflation number. So the tokens minted are a percentage of the yearly inflation, right?
Yes.
So you know then how many tokens you minted and what percentage they represent over the total supply,
Yeah.
and then
No, no,
you're
but here the problem is how at initialization time of the contract, how to let these percentages to be coherent. That is the
right.
problem. That is
And
the problem.
what's the fail state? So explain the fail state to me, because all right, so when the
Wrong
contract,
percentage. Wrong percentage. Let's see that you said send, for example, 100 percentage here, 100 percentage here. Okay, but in this case, you have no tokens. Okay, because you already send everything in the raw token components. The transaction goes in fail, it reverts, and no one can, and the fixed inflation doesn't work. That is the
right,
problem.
right, okay, so I understand. So you're deploying the contract saying 100% of the tokens should be sent, but you do it twice. So the first step sends 100, and you cannot send
Uh,
100 again.
not twice, not twice, because the amount of tokens to be swapped, okay,
Hmm.
is the percentage remaining from here, from the
From the
raw
raw
token
token
components,
component. Okay.
okay,
And then
okay,
that becomes a new balance, which is the swap token components, right? Which is 100%. I mean, even if you
yeah,
swap, because if you swap 0% of something, zero is still 100% of the new number, because like zero is 100% of zero. So
yes.
it wouldn't really fail if there, like, I don't know if like the logic would fail, but the math wouldn't revert, because it would just say send zero tokens to these components if no tokens reach that point. Because
But
like the
send zero tokens can fail because you don't know how the internal engine of the tokens, neither the swap one works. So, for example, if you call the transfer method using zero as value of tokens, okay, the contract of the tokens must have the require that says value zero cannot transfer,
right,
and
right,
all the
you're
transaction
you're
will
correct.
fail.
Now the thing is that if you use any number that's not 100%,
Mhm.
wouldn't that, because a percentage is relative to a number, right? So it's like 100% of a number. So
Yes.
in the raw token components, you're saying, okay, swap 100, like let's say swap 90% of the minted tokens. So if you mint 100 tokens, you're swapping 90, and you're keeping like 10, right? Now, the thing is that these swap tokens are now, like, 90 is 100% of the swap token components. So if you said again 90%, then the second component would actually send 81 tokens to its intended target, because 90% is, I mean, 90% of 90 is 81.
Mhm.
So I don't like, that's why I think that this setup at least doesn't wouldn't cause a percentage mismatch between them, because they're percentages of different things.
It could be because we have the destination dilemma, let's say, because the destination is someone linked to the raw token components or the swap token components.
Right, but
And
that just means the same person gets both things, but that doesn't mean they wouldn't get enough tokens.
I don't know. I don't know.
I mean,
I don't
I'm just
know.
trying to understand the numbers, right? Because you're saying raw tokens components, like, call it that's one balance, right? Your balance of row tokens, and then you have a percentage for that. And then swap token components is another balance, and then you have a percentage for that one. So
Mhm.
percentages don't have to match
But yeah,
between.
but we must be but we must be sure that could be even 1%
Works.
of yes of
Yeah.
to call the swap tokens just if the components keys list length is greater than zero, different from zero.
Right. So you just have to make it so it's not 100%.
Exactly, exactly, exactly. So here what we can do. Here what we can do. First of all, let's say that the destination is the first one that receive tokens. Okay,
Hmm.
so it will be linked to value is ETH true. It is linked here to the swap the token components.
Right.
If not, row token components. Okay,
Hmm.
and that's it. First of all. Second of all, if we have true here or the second list length is different than zero,
Hmm.
this number must be the length of this percentage is the first one I mean must be equal to this because the swap will take the remaining one.
Right. So you're saying, okay, and now my other question is, why, like, do we have a situation where we distribute tokens that are not swapped? Like, I guess that's for the farming
Yes,
inflation, right?
the farming.
The
Yes,
farm, and that could be multiple addresses too. So
sure.
you're basically dividing between the farm. Well, it's there's also ETH farming, right? So you also have
There
to
is
pay for
also
ETH
it
farm.
farming, but it's not involved into the fixed inflation. The
Okay,
farming is into the investments manager.
okay. So in this case, the ETH from the fixed inflation is who, like, which components get ETH, like the delegations, right?
No, in this case are the treasury splitter, in our case, I mean,
Uh huh.
and the destination wallet and the common treasury.
So it's a okay. So it's a number of treasuries.
Yes, there is a number of treasury. Also, there is another difficulty level, which is the executor reward will be always expressed in Ethereum because it is a reward based
On the
on the
fee.
gas fees you
Right,
spend.
right. So if the price of the token goes down, you have to pay more tokens to the executor because otherwise it wouldn't.
No, 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 no. It is
Oh,
fixed, man.
I mean, you have to sell more tokens
Yeah.
to get that amount of ETH. I mean, it's the same.
Yes.
Um. Okay. So
This means that there will always be this could be a help for us because there always will be a swap on Ethereum, and
mhm,
this is good for us. This is good for us. This is good because this means that this list of percentage must be always similar of the same length of the components.
right.
No, 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 no. What?
Mm,
Yes, 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 yes. We need to write down something here. Let me just take some notes here. Okay, first of all, step zero means
mm-hmm.
step one,
Swap
not swap.
or
Send, send to row
okay.
token components.
Now, if you're sending and then swapping, can you just
including destination, sorry, including destination if value z is false.
so I have a question. In the logic for calculating how many tokens to swap, since you only have like raw tokens and swap tokens, once you send the raw tokens, can you just swap anything that remains? Because you don't have
Yes,
to
that
number.
this is the logic. This is the logic.
Okay. Okay.
Sorry, I just here. I'm writing. Then I will explain. Okay, you must specify the default the default component that will receive tokens. If no specified, treasury manager is the one. Okay. So first of all, the first check you need to do have is this. Did you ever set a destination? Because, for example, your logic cannot have a destination. For destination, I mean a wallet that will receive money for the company. Let's say something external that can be changed and also released. Okay. So let's see that you do not specify the destination percentage, which is 0. You're done. You're done. You don't have to check anymore.
Mhm.
But if the percentage is different than 0 and the destination released the destination wallet, okay, so the destination wallet is 0 but it has a percentage, you need to specify who is the component that will receive that percentage
Right.
at its place. If you don't specify a default component, you must use the treasury manager as the destination, the replacer of the destination.
Okay.
Because in our logic, as I said, every organization must have a treasury. So the other components are not useful, but the treasury manager is. Then you can mint. Then you can send two raw components, including destination, and the percentages must be the same of the must be the same of the components, and some must be less than 100%. Then 2, swap. Then 3, send to the executor, send percentage to the executor. If value set is true and destination, including destination, if destination percentage is different from 0 and value is it, if try send send to destination if destination no, I can just copy this values it. Send swap tokens to swap token components. List can be 0. If not, percentages length must be
Greater than 0.
Less
Then components.
but 1 less components. Yes. This because, so if the list is 0, let me check.
If the list is 0, shouldn't it go to the treasury manager?
Yes.
Like on the other logic?
Yes. List can be 0. If yes, no, why if list is different 0, percentage must be less of the components. Otherwise, everything, the rest goes to treasury. Okay, I like it.
Yeah,
I like it. Makes sense. Destination wallet address, destination wallet owner, destination wallet address, destination wallet percentage, value is it, bytes 32.
You should call it is raw or is swapped It's gonna be easier.
Is raw. Bytes 32, default component key. Default destination component key. Okay, sorry, value is, it must be is raw. And this is true. This is false. Okay, I think that we can work on these. We can work on these. We can work on this logic of this method.
Yeah.
Let me just cut it and copy over here. At the end, let's say. Okay, first of all, we need to change something. I think that set destination can be set like this. Okay, let's just destination wallet percentage. Destination is raw. Let's go. Okay, okay. So we need to put all this stuff here. Default destination component key. Okay, let's start with the simple things. Go here. Where are the destination things? Destination wallet percentage. Is that the name? Cool. Destination is raw destination component key. Okay. Private destination is raw. Bytes 32 private destination, default destination component key. And that's it. So the first thing we need to go here and do a lot of change. Token receiver percentage. Yeah, all this stuff must disappear because what is this? Token receiver percentage is not used anymore because here we have raw tokens components and swap token components. So I can, okay, here I did this because of the lazy init component, the lazy init capable element logic. The lazy init is a bytes. This bytes is divided into 3 bytes. The destination wallet, the token receiver percentage, which is wrong. Okay. So the first thing to change here is destination wallet owner, destination wallet address, destination wallet percentage, destination is raw, and default destination component key. So it is address, int, bool, and bytes 32. And this is the first thing. Last token percentage, 1 year, days in year, token to mint address. Token to mint address. So the fixed inflation knows the token to mint. I think that this is good because it must know also the MN plugin and liquidity pool addresses and swap parts. So I think that it is okay. So we set the destination wallet, if any, which is here. Now we're going to set the basic info. Okay, and the basic info are okay. Let's do like this. No. Okay, sure. Okay, I like it. So in the lazy init data, and here we solved the destination. Now let's, okay, I think that we need more methods to do not have the stack too deep error. Let's see if we can do, okay, same thing. Function initialize destination data. Private bytes memory destination data. Let's see. Everything goes here, and this is good. Destination data, no. Destination data, and so the first thing we can do is initialize destination data. Cool. Then do initialize so maybe it could be the first initialize token, no, for contract invariants. Data. Which are the invariants are, for example, the rest address, the executor reward percentage, the how many. I think that here we can now put hard cable data, because 1 year in seconds. How many seconds for 1 year? How many seconds in a year? Whoa, it's a huge number.
You can multiply 604,000 by 365.
How much? Sorry, 600?
I mean 6,400, which is how many blocks there is in a day.
No, it is expressed in seconds. 1 year in seconds.
Oh no, it's not in blocks. You need
no, not in blocks anymore.
Okay, then that's different. Well, you can multiply blocks times 15, but it's.
I have the number over here, but it is too complicated to read because it is written like this. I need to do my usual magic tricks. Go to our wonderful Ethereum SOS website. Connect MetaMask. Just open the console and type. Oh my god, my computer is so slow.
You need to get one of those 32 gigabyte RAM sticks.
Yes. Number 2, no. What, 3? It's UBN. Number here, .toString. No. No. E7?
Bingo.
Okay. I think that it is correct. Days in year is 365, so this means that we can change this in constant. So we can delete this, okay? We will think about it later. So the press address, the executor reward percentage, token receiver percentage can be deleted. Rest address and executor reward percentage can be moved here. The token to mint address. Let's see. Yes, token to mint address. Last token percentage. Swap to ETH interval. No, this must change the name. It is not swap to ETH interval anymore, but execution event, execution interval. Execution interval. Okay. And this is last execution event. Last execution event. This is not first swap to ETH, but first execution event. Okay, so contract invariants are pressed address and token to mint address. So they are address, uint 256 and address. Okay. Initialize destination data. Okay. Then we can have initialize execution data. Execution data, where the variables are last token percentage, first execution event, execution interval. Okay, so I need to introduce these new variables here. First execution event, execution invert interval. Click. Execution interval. Execution data. And now the inter part of code here. Okay. So this part can be deleted. This part can be deleted. Okay. Contract invariants can be deleted. Initialize contract invariants. lazy data. Then we can initialize execution data. Now we need other two initialization methods, which are, let's see, initialize components data, and even swap data. Initialize swap data. Components. Okay, let's start from the IMM plugin. Liquidity pool addresses. Okay. Initialize. Okay, this can be recycled here. Swap path. IM plugin. Liquidity pool addresses. Swap path. Okay. Address. Blah blah blah. Okay, and here I can write to do. Okay, let's do require IMM plugin different address 0. IMM. Okay, well, guys, I think that it could be enough for today because we had 1 hour and a half of recording, and hope that you liked the way we managed this. And please, if you have any questions about this, just share with us. And I want to take Atox for the help and the good questions. Please pass me the AP you were talking about.
Yeah, sure.
Okay, and then we can see for the next Vasa appeal. Thank you very
Awesome.
much. Bye bye.
Bye, guys. Thanks, Vasa. Have a good day.
Have a good day. Bye bye.